Here at the bottom part of the barrel is actually cold from the CO2. It went up about 20-30 feet through these tree branches, which was designed to stop it, and then it come just tinkering back down and landed somewhere down here. Hi everybody, welcome back for another video. Today we're making a homemade improvised CO2 cartridge launcher. Stay tuned. I call it the MacGyver rocket launcher. We got just a little bit of everything. It's all highest household items, and we got projectiles. And what I was doing was dropping it and piercing the CO2 in this manner, and then it would basically, by the force of the air pressure coming out, it creates a propulsion, almost like a rocket. It propelled upwards. And it's a very simple design, and I really am not interested in trying to design a device to shoot these, but I am interested in the physics and the weight and the joules and what this can actually do. This is an 8 gram CO2, liquid CO2 inside. When it's punctured, it turns to a gas form, and the gas comes out and propels this forward. The canister is 21 gram. And what happens is that 8 grams CO2 comes out, and then you create a 21 gram projectile. It's a blunt projectile, but is a projectile. And so what I did is I bought a shower curtain rod. This is one end of a shower curtain rod. This is one half, and this is the half that you don't use. But this is the half that has a spring and some other parts. But you can take the other side, which is essentially the same here, and it has two ends that are open. I've actually got both of them open at the moment. And it has an end that just goes on, just like this. And so what I did was I took this end and I hammered in a couple nails here, 3 of them, because I found that one of them was never centered perfectly enough. So what I did was I created 3 of them in there. And so now you can see 3 different pins. It increases the chances of it striking the 8 gram CO2 in the right place by 3-fold. And you can adjust these so that they're spaced out pretty evenly. And when it comes down with enough force, and it will lodge in one of these. So you just push it in, and you can see it actually went in and connected in one of them, and it pulls right back out. And so you have this ability to fire this using these pins. This on the end, and then drop it in, and it goes down. And the bottom part has to be braced on some solid surface. So you saw in the video where I had this inside of a heavy pot, because I didn't know what would happen down here. I didn't know if this would blow up and that piece would go flying around. Looks like none of that happened. Looks like what happened was just what you would expect. It fell in, and this was sufficiently stable on the base. I don't know if air came out around this seal, and this is loose. It's not sealed. It's not permanently fixed. But there was enough propulsion coming out at the top up here to send that thing up about 30 feet. So that's a 21 gram projectile being launched out of here. And it's not a bad setup for doing some physics testing. It's not something that's really practical, because in a horizontal version, you could, in theory, you could shoulder this, but how do you pierce the CO2 without some sort of trigger mechanism? If you take this thing, you have it loose, and you try some sort of slap like that, in theory that would work, but what happens is the CO2 just goes forward, and it does not pierce the CO2 the way you would like. So the real goal is to get these things to pierce the CO2 so that it really is in there. And at that point, then it will just launch and take off. So what we want to find out is this really useful as a projectile? Is there any future for this as a potential form of ammo? And I'm using the 8 gram because this is significantly smaller cartridge. It's lighter. It should launch a little faster. I know it has less CO2, but there's sort of a balance between the weight of the cartridge and the amount of CO2, and I figure 8 grams seems reasonable to start, but of course you could try 12, you could try 16. It could get larger because there is not a perfect bore match here. As you can see, there's plenty of room. So if I had one that was a little bit wider, it might actually fire better because you'll have less air being lost. I know there was air coming out, but that's normal. But it's probably not bore match the best. And I was really surprised that it actually launched at all. I figured that we just might lose all of our air through blow-by. Did not seem to be the case. This thing launched. And there are other videos on YouTube with people doing very similar launching using various pipes. This is nothing fancy. That's my point here. This is a shower curtain rod, as you can see. And so something that you can buy easily and test. And so I'm going to give it a try and we'll see what it does. All right, this is my setup. Same thing I had outside. Big heavy pot. Got the barrel. This time I'm going to put a piece of wood, pretty thick wood on top. And you're probably wondering, how am I going to drop the CO2 down inside with the wood on top? I can't do it that way. And so I can, just hold the string, and then when I let go of the string, it will drop. Just a little lasso. And so I can do this safely from about 20 foot back, and then it will drop, and then we'll see what happens to the piece of wood. Fired. Well, there's always something to learn from these experiments. This is our 8 gram CO2 projectile. It's actually still cold, but I was able to get it to shoot on camera. And I pretty much was expecting, it's very weak. The power was not able to do anything to the wood. Let's take a look at the backside of the wood here. See if there was any. Now, I couldn't see it originally, but there is a dent into the wood. That's the extent of it. Really weak. It fired. Let's see what kind of puncture we got this time. All right, it's cold. That's a pretty decent puncture this time. Not perfect, but definitely got it to fire. And again, there wasn't a lot of power, but it had to push this long projectile here as well as the cartridge. Both were ejected. Well, it went. That was 12 gram CO2, not really any better from what I can see. Let's go take a look. But we have a nice cold CO2 here, and now we're getting good punctures. And you saw how it launched. I'm getting the first shot with the 8 gram CO2 was hitting somewhere up in here, and there's even a little spot from where that hit. This one I think hit somewhere down below, and it's launching this, and which I haven't weighed yet, but it's a spear with a sharp tip, and it's the only way that I feel that I can safely puncture the CO2. But it's launching. So what I eventually came up with was a fairly reliable system compared to what I was using originally, and I'll show you what I did. If I take this off the bottom, I have an inner barrel, and the inner barrel is much more tightly bore matched. So for what it's worth, this short barrel is pretty tightly bore matched to an inner pin, and I don't know how well you can see inside, but I have only one pin in there now, right in the center. And basically this thing fits over that one pin, and the CO2 goes in very snugly, and it goes down, and then this snaps on right at the pin, and it'll go in place. It goes in place easier when the CO2 is further back, and then it goes in place. And so now you have the CO2 positioned just on top of the pin, and I'm using the pole to press it down through the barrel. Because this thing is in the way, you're not getting the full power. This is a lot of weight to push forward, and this is a long, heavy spear, and it's launching the canister as well. So that's really launching just like this from inside. That's a lot to send 20 feet. It without having this in the way, just pierce it. I think these things may do a lot better if we're getting a really good puncture, and that's the key.